Welcome to the presentation on classification of matter. So we're going to look at some pictures here, and you're going to have to decide what the difference is. So you're going to look at the pictures on the left and on the right and try to figure out what that is. So the first picture we have is some cows. If you look at some of the features of the cows, what do you notice? Yeah, they're all brown and white. They all look very similar. Now look at this group of cows. Again, they're all cows, but do you notice anything that's different? Look at this group of tennis balls. Now compare that to a group of different colored balls. How about these guys, the flamingos? Now, interesting thing about flamingos is they are pink because of what they eat, which is mostly shrimp. Now look at these budgies, which budgie is actually a native word in Australia for good eating. Ironic, right? And what do you notice about the pictures on the left and the pictures on the right? Go ahead and pause for a minute if you want time to think. That's right, the left side, they all look the same, or at least they're very similar. And on the right side, they all look different. There's a variety of things. And yes, sometimes it's just in the definition. You could argue that everything on the right side is just cows, balls, and birds. But again, we've pointed out some of the differences for you. So what's the matter? I guess the answer to that is everything. Everything we can touch and feel is made of matter. So now imagine you had a piece of paper, and you keep tearing it in half. We'd eventually get the paper so small that we can't tear it anymore. Now imagine you could just keep tearing it. You have the little microscopic tweezers, and you could do what Ant-Man does and get down to a very small level and just keep tearing that paper up. Eventually you'd get it down to a single atom. When we think of matter this small, we can classify it. So there's two types of classification of matter we're going to look at, pure versus mixed. Imagine a bag of Halloween candy. There's generally two kinds of bags that you can have. The first one is you went trick-or-treating, and it'd be a bag with a variety of candy. You go to different people's houses, they all buy from different places, and they give you each one piece of their candy. It is a big mixed bag of candy. Now, pretend you don't like going trick-or-treating, or you just want to go to Superstore the week after Halloween and buy it on sale. You might just buy a big bag of candy that's all the same. This is exactly what I do, because I love my peanut butter cups. The one that is all the same is considered pure. So in this example, it'd be the Reese's peanut butter cups, because it's pure peanut butter cup. The one with different kinds is called mixed, because it is a mixture of candy. Now keep a hold of this candy analogy, because we're going to use it later. Now let's pretend we reach into this bag, in this case a jar. If you take one piece of candy from the bag, do you know 100% what the exact candy you're getting is? Well, in the pure bag, you would. Everything you're going to get is a Reese's peanut butter cup. In the mixed bag, you'd have no idea. Maybe you get a Snickers bar, maybe you get a Mars bar, maybe you get a lollipop. So if you know what you're going to get, because it's all the same, it is a pure substance. If you're unsure what you're going to get, well, you might know it's one of 4 or 5 kinds of candy, but you're not sure which one you're going to get if you only take one piece. That is considered a mixture. So in a pure substance, everything is the same element or compound. Or in a mixture, you have different elements or compounds. Pure substances. Pure substances, we know what kind of candy we're getting. Now there's 2 kinds of pure substances. There's either elements or compounds. Element is you have one single kind of element. So if you look at the periodic table, it is one of those things off the table. Now you can have more than one of that specific element. So our examples would be Ni, which is nickel. So you have just one piece of nickel, or one carbon, which is C. But what if you had 2 hydrogen together? Well, that's still only one kind of element, so it is an elemental pure substance. And the same thing would go with oxygen. You have 2 oxygen elements, therefore it would just be an element. Or compounds, it's still one kind of compound, but compounds are made of elements. So the example we have are carbon dioxide and H2O. Now the carbon dioxide, it has carbon and oxygen, but they're stuck together. And then in the H2O, you have hydrogen and oxygen, and they're stuck together as well. So although you have multiple elements, you only have one kind of compound. Again, we'll see more examples of this later. In a mixture, we reach into the bag, we don't know what we're getting. Now there are two kinds of mixtures. The first one is homogeneous. Now homo is just a word for same. Now it's two or more substances, but the reason we call it the same is because we cannot see the different parts with our eyes. Now this isn't using a microscope or any extra device. I mean, if you have glasses, okay, you can use your glasses, but it's can we see the different parts with our, what we call naked eye. Heterogeneous means there's different. There's still two or more substances, but we can see the different parts with our eyes. Okay, now an example of a homogeneous mixture would be Gatorade. When I look in that Gatorade bottle, I just see a yellow, blue, orange, green liquid. I know there's different stuff in there. I know there's sugar and I know there's water, but I can't see the different parts. Or with heterogeneous, look at this pile of rocks. There's different rocks in there, and yeah, I can see the different kinds of rocks. There's different colors and different shapes and different sizes. Now once we know all this, we can just make this nice little decision tree that can help us kind of get through to figure out what things are. So the first thing is everything's matter. Now, do you know what you're getting? Well, it's either yes or no. If you know what you're getting by reaching in that bag, remember, it's a pure substance. If you don't know what you're getting, well, then it's a mixture. So let's look at the yes side for a second here. If it's yes, if you only have one element, well, that's right, it's an element. It's only one type of atom. It cannot be further broken down. The examples we used before, nickel, carbon, 2 hydrogen, and 2 oxygen. Under this one, when we have 2 more elements, what do we call that? That's right, it's a compound. It's only one type of molecule, which a compound and molecule basically mean the same thing. And you can have 2 or more types of elements, but they are stuck together in some way. Okay? And so, again, the example we use is carbon dioxide and H2O, water. If it's a mixture, if we can't see the substances, then that's a homogeneous mixture. You have 2 or more pure substances. Now it can be an element, let's say an element and a compound, or 2 compounds, or 2 elements, or 3 elements and 5 compounds. It could be any sort of number of these together. Okay? But the key is that we cannot see the different substances with our eyes. So if we take a look at salt water, if you take a little bit of salt and mix it in water, we know there's salt in there, we know there's water. So we know there's more than 2 things, so therefore it's a mixture. But I can't see the salt or the water because they've dissolved. They've gone into what we call solution. Or if you look at Play-Doh, you mix, I don't know, what's in Play-Doh? Borax and, I don't even know, borax, flour, salt, whatever you want to put in it. And then you put in a little bit of food coloring. And you mix it all together. And if you mix it really good, I can't tell the different things I put in there anymore. Okay? And that's why it's homogeneous, because it all looks the same. Now take a heterogeneous, for example. You have 2 or more substances. It's the same as homogeneous, but you can see the different substances with your eyes. So think of a garden salad. You know, you got lettuce and some tomato, maybe a little bit of chopped onions. Okay, you can see those different parts in the salad. Or if you look at a Big Mac, you got the burger, and you got the bun, and you got the cheese, and the Big Mac sauce, and the lettuce. You can see all those different parts. And that's why it's heterogeneous, because I can see the different parts of the mixture. In this case, I've called it a solution. Should be mixture. So now we're going to check our understanding. Now, be warned, these images are all the way at the atomic level. Remember we talked about being Ant-Man and getting down and being able to tear things up into all the way to the atomic level. So we're going to look at these pictures. I encourage you to pause the video between each one so you have an opportunity to decide what you think it is. So the first one we're going to look at is this upper left-hand side. Okay, what I see is little groups of 3 circles. 2 of them are colored white, one's colored black. Now would this be a pure substance or a mixture? Well, if this was a bag and I reached in without looking, would I know what I'm going to pick out? Well, yeah, everything I would pick out would be 1 black and 2 white. So therefore it is a pure mixture compound. Now it's a compound instead of an element because we have different kind of shapes in there, or different colors. Okay, and each one of those is representing a different kind of element. But it's still pure because I know what I'm getting. Where if we look at this one here, yeah, it has white circles and black circles, but are they all put together the same way? If I reached in, would I know exactly what I'm getting? No, I wouldn't. That is why we call it a mixture. Now, if you note, I didn't say it was if it's homogeneous or heterogeneous mixture. That is because we cannot tell. We're looking at this at an atomic level. We're not using our naked eyes, so we don't know. So it is perfectly fine to just call it a mixture if you are looking at it like this. Our third one, let's take a look. Okay. Now going back through that tree, do we know what we're getting if we reach in and grab one item? Remember, you're grabbing them at random. Well, of course not. We don't know what we're getting. You can get a white circle, a black circle. You can get like one of these little groups. So in that case, yeah, it's going to be a mixture. And then if we look to the right, well, I mean, same thing, right? I reach in, I don't know. There's two different things I can get. I don't know which one I'm getting. It's not 100%. I'm not going to bet my house on it. Okay, so again, what would this be? Yeah, of course, it's a mixture. Okay. Down here in the bottom left, well, I see little shapes, and there's 2 white circles, and they're stuck together. Okay, everything looks the same, so I know what I'm getting. If I reach in, I'm grabbing 2 white circles, but the question is this a compound or an element? Well, when we look at those circles, do we have different kinds of circles, or are all the little circles the same? Well, they're all the same. So this would be that example of 2 oxygens stuck together or 2 hydrogens stuck together. So this indeed would be a pure substance, but an element. And then if we look over here again, I mean, you're probably pretty good at this by now, I would hope. Everything looks the same, so we know what I'm grabbing, so it's definitely a pure substance. Now, is this an element or a compound? Do all the little circles look the same, or do we have different circles in there? Well, we have different circles, so again, this would be a pure substance, but a compound. Now let's take a look at a more real-world example. On the upper left, we have milk. Now that's not milk, that's water. I was just thinking about milk, because the cows earlier, I guess. So this is just a glass of water. Now we're going to assume it's distilled water. Okay, so I guess you could argue with me that my answer is wrong, but I'm going to tell you it's distilled water, so pure water. Now is water an element or a compound? Well, water is made of 2 hydrogen and 1 oxygen atom, so this would be a pure substance, a compound. Now over here I have one of my favorite little snacks, a bowl of mixed nuts. I see some almonds and some cashews in there. Now, obviously we know this is a mixture. They all look different, okay, and all the nuts are different. But the question is can we see the different kinds of nuts in there? Well, yeah, we can. So now we can actually go ahead and say that it is a mixture, but we can call this a heterogeneous mixture. I mean, I don't have it here, but you would be able to call it a heterogeneous. Now, if I look at this Jell-O, okay, they all look the same. They're little cubes. I guess you can argue, well, the cubes are different shapes, sir, but we'll just, looking at the actual Jell-O, we're not paying attention to the bowl. Again, this would be another mixture, but we could call that a homogeneous mixture because everything in there looks the same. And we cannot tell the different parts. I can't tell you where the sugar is or the gelatin is. Okay? Fun fact about Jell-O, it's actually not vegan usually because they have gelatin in there, which is boiled bones from animals. Now this Jell-O, on the other hand, it's going to be a mixture, of course, but is it going to be heterogeneous or homogeneous? Well, I can see the strawberries and the blueberries and all the different parts in there, so it's still a mixture, but we're going to call it a heterogeneous mixture. Down on the bottom left, we have copper. Everything in here looks the same, and I've told you what it is, which is copper. Now, if you look on your periodic table, you're going to find copper directly on the table. It's going to be a pure substance, and it's an element. And over here on the right is salt. Salt is just 1 sodium atom with 1 chlorine atom stuck together. And this is pure salt. And that's going to be a pure substance, but a compound again. Well, that's all I have for you today for classification of matter. I hope it's been helpful. Make sure you download the PowerPoint, which I'll attach as well, and there should be some activities for you to work through. Okay, take care.